Section 8-4 is entitled Trigonometry, or more correctly, right triangle trigonometry. Trigonometry itself is the study of triangle measurement. And what we'll be looking at today is three trigonometric ratios. And that is a ratio of the lengths of two sides of a right triangle. And there are three trig ratios that we will be taking a look at today and we'll be using in this section. They're entitled sine, cosine, and tangent. So for example, the sine of angle A is the ratio of the length of the leg opposite angle A to the length of the hypotenuse. So imagine you're standing at angle A and you're looking out. The side opposite is segment BC, or the length of that is little a. So you take little a and divide that by the length of the hypotenuse, which is C, and that gives you the sine of angle A. Now the cosine of angle A is the ratio of the length of the leg that's adjacent to angle A to the length of the hypotenuse. So cosine is the ratio of the adjacent leg, in this case segment AC, the length of which is little b, divided by little c. Cosine is adjacent over hypotenuse. And the third trigonometric ratio is the tangent. And the tangent of angle A is the ratio of the length of the leg that's opposite angle A to the length of the leg adjacent to angle A. So the length of the opposite divided by the adjacent. And you can take the trig ratio also, you could also do these three ratios for angle B as well. You would just be looking at difference. So in this case, little b would be the length of the side opposite angle B, and little a would be the length of the leg that's adjacent to angle B. We never do the trig ratio of the right angle because that's the 90-degree angle and we already know a lot about it. Here's an easy way to remember some of this. Okay, here's our triangle again. So the sine of A, and we abbreviate sine S-I-N. It's not pronounced sin, it's sine. Sine of angle A is the length of the opposite side over the hypotenuse, or in this case, little a over little c. The cosine of angle A, which we abbreviate COS, and we say the word cosine, cosine of angle A, is the adjacent over the hypotenuse, or in this case, little b over little c. And the tangent of angle A, or as we write it tan, but we say tangent, A, is opposite over adjacent, or little a over little b. An easy way to memorize these, and you will have to memorize them, is with the word SOHCAHTOA. SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Memorize that. So the first set of homework problems are going to take a look. Actually, I think you just have one homework problem that looks like this. Find the sine of angle A, the cosine of A, the tangent of A, the sine of B, and the cosine of B and the tangent of B for triangle ABC. Express each ratio as a fraction and as a decimal rounded to the nearest hundredth. So let's take a look at the sine of angle A. So in relation to angle A, the opposite side would be 3 and the hypotenuse would be 5. So the sine of angle A is 3/5 and as a decimal, rounded if necessary to the nearest hundredth, this one is actually exact, is 0.6. Sine is opposite over hypotenuse. The cosine of angle A is the adjacent over the hypotenuse, or 4 over 5. And 4/5 is 0.8. And the tangent of angle A is the opposite over the adjacent, or 3 over 4, which is equal to 0.75. So those are the three trig ratios for angle A. Now let's imagine we're standing at angle B, and we're going to do sine, cosine, and tangent for angle B. So the sine of angle B is the length of the side that is opposite angle B, which is 4, divided by the hypotenuse, or again 0.8. The cosine of angle B is the length of the side adjacent, which is 3, divided by the hypotenuse, which is 3 over 5, or 0.6. And the tangent of angle B is the opposite over the adjacent, or 4 over 3, which is approximately 1.33. I know these sound a little strange, doing sine, cosine, and tangent. What does it really mean? One way to think about it is it's something that we do to an angle to help us figure out the relationships between the sides, and as we'll see, it can help us to find the length of a side or the measure of an angle. Here are 3 problems that help you to solve a triangle. We're going to find x and round to the nearest hundredth. So we're given a right triangle that has of course, a right angle, a 52-degree angle. One leg is 13, the other leg is x, and we don't know anything about the hypotenuse. So what we're going to do is take the sine, cosine, or tangent of this 52-degree angle, because that's the information we're given. So ask yourself, in relation to this 52-degree angle, what is opposite, adjacent, and hypotenuse? Well, there is only one hypotenuse, and we don't know anything about that, so we can't use that. But in relation to this angle, x is the opposite side, and 13 is the adjacent. The trig function that uses opposite and adjacent is tangent. So we'll take the tangent of the 52-degree angle, and that's equal to opposite over adjacent, x over 13. That's half the work right there. Now we just need to solve for x. I'll multiply both sides by 13. Okay, so 13 times the tangent of 52, and the tangent of 52 should really be thought of as one number. You can't pull that 52 away from the tangent. Okay, now enter this into your calculator. 13 times tan, hit the tan button, 52. And x is approximately equal to 16.64. Rounding to the nearest hundredth is 2 decimal places. So the length of the other leg is approximately 16.64 units long. Here's a second example. Again, we have a right triangle. We have a 61-degree angle. One leg is 24, and we're asked to find the length of the hypotenuse. So this time we won't be using tangent because we have to find the hypotenuse. In relation to the 61-degree angle, 24 is opposite the angle and the hypotenuse. The trig ratio that uses opposite and hypotenuse is the sine. So I'm going to take the sine of 61, the 61-degree angle, and that's equal to opposite over hypotenuse, 24 over x. Now we need to solve this for x. And this is a little tricky because x is in the denominator. So it's really a two-step process here. I'm going to multiply both sides of the equation by x. And now divide both sides of the equation, not by 61, but by the sine of 61. Remember I said you cannot separate the sine and the 61. So x is equal to 24 divided by the sine of 61. And punch that into your calculator, and you'll get approximately 27.44. And our third example, again a right triangle, and the angle at the top is 27 degrees, and we have one of the legs is labeled x and the hypotenuse is labeled 19. In relation to this 27-degree angle, x is the adjacent side, and we have a number for the hypotenuse. The trig ratio that uses adjacent and hypotenuse is cosine. So we'll be taking the cosine of a 27-degree angle, and we need to do adjacent over hypotenuse, x over 19, and solving for x, we'll multiply both sides by 19. Punch this into your calculator, 19 times the cosine of 27, and you'll get that x is approximately equal to 16.93. One thing I should mention is be sure you check on your calculator, press the mode button, and make sure that you are in degree mode, not radian mode. If you have a question with that, come see me. So we can actually do this kind of in reverse. If you know, or if you can find the sine, cosine, or tangent of an angle, you can use the inverse trig ratio to find the measure of the angle. In all the examples we previously did, we knew the measure of at least one of the angles, other than the right angle, and we used the trig ratios to find the length of a side. If I know the length of two sides and can use sine, cosine, or tangent, I can figure out what the measure of an angle is. So inverse sine says if the sine of angle A equals x, then the inverse sine of x is equal to the measure of angle A. And notice this funny notation. It looks like sine to the -1 power. It's not. That's a notation that means inverse. In the same way, the inverse cosine, if the cosine of angle A is x, then the inverse cosine of x is equal to the measure of angle A. An inverse tangent, if the tangent of angle A equals x, then the inverse tangent of x equals the measure of angle A. I'm sure this is a little confusing. Let's take a look at 3 examples that use this. So we need to find the measure of angle A to the nearest tenth. Now, so I need to find the measure of this angle right here. And in relation to that angle, 6 is the opposite and 20 is the adjacent. So opposite and adjacent are tangent. So I say that the tangent of angle A is equal to 6 over 20. Because with regard to angle A, it's opposite over adjacent. Now I can't put this into my calculator because my calculator will take the sine, cosine, or tangent of an angle, a number, and I don't have that. But what this means is that the measure of angle A is equal to the inverse tangent of 6 over 20. So I know the tangent of the angle, which is 6 over 20, but I don't know the measure of the angle. So I'm going to use the inverse tangent to find that. Now you can use this on your calculator. You need to hit second tangent button, 6 divided by 20, and the measure of angle A is approximately equal to 16.7 degrees. Our next example, finding the measure of angle A. In relation to angle A, 3 is the adjacent, and 15 is the hypotenuse. Cosine is the trig ratio that uses adjacent and hypotenuse. So the cosine of angle A is 3 over 15, adjacent over hypotenuse, or the measure of angle A is equal to the inverse cosine of 3 over 15, which when I plug that into my calculator is approximately equal to 78.5 degrees. And my last example, to find the measure of angle A, in relation to A, 5 is the opposite, 9 is the hypotenuse. Opposite and hypotenuse are used by the trig function sine. So the sine of angle A is opposite over hypotenuse, or the measure of angle A is equal to the inverse sine of 5 over 9, which is approximately equal to 33.7 degrees. And the last concept is solving a triangle. To solve a triangle means to find the missing angle measures and the missing side lengths. Here are a couple examples. Solve each triangle, round measures to the nearest degree, and side lengths to the nearest tenth. You'll notice I know that this is a right triangle. I know the length of the hypotenuse is 10, but I don't, oh, I think I was supposed to put the measure, I think I was supposed to put a 62 in there. Okay, yeah, so I do know that angle B is 62. So to find the measure of angle A, this is really easy. This was back in chapter 5. 180 minus 62. So the measure of angle A is 28. And I can actually add that in there. I think I may need to use that. Now I know the measures of all of the angles. So if I want to find the length of side B, B is opposite 62. So the sine of 62, remember sine is opposite over hypotenuse, is B over 10, or B is equal to 10 times the sine of 62, which is approximately 8.8. I guess I could use the Pythagorean theorem at this point, but I'm enjoying using trig ratios, so let's keep going. In relation to this 62-degree angle, A is adjacent, so the cosine of 62 is equal to the adjacent over the hypotenuse, or A is equal to 10 times the cosine of 62, which is approximately 4.7. So I found the length of every angle and every side in this triangle. And let's take a look at our last example. In this case, I don't know any of the angles except for the right angle. I know that one leg is A, one leg is 9. I'm sorry, one leg is A, one leg is 6, and the hypotenuse is 9. In this case, I'm going to have to use the Pythagorean theorem. So A is equal to the square root of the hypotenuse squared minus a leg squared, which is approximately 6.7. So A is approximately equal to 6.7. And I can actually, I think I'm going to try to find angle B here. Because I don't need to use A to do that, I can do opposite over hypotenuse. So the sine of angle B is equal to 6 over 9, or the measure of angle B is equal to the inverse sine of 6 over 9, which is approximately 42 degrees. And then actually, now that I know that that's 42, I can find the measure of angle A by just subtracting from 180. And the measure of angle A is going to be 48 degrees. And that's it for basic right triangle trigonometry.